Hi, my name's Kyle Kramer. I'm researching the CSU Chemicar stopping mechanism. So the Chemicar is powered by a hydrogen reaction and stopped by a magnesium hydrochloric acid reaction. So I'm going to be researching this hydrochloric acid and magnesium reaction. Based on how long this reaction occurs uh, is how long the car runs for. So if we know how long the car runs, we know when it will stop. And that's incredibly helpful when we take the car to competition. That's the whole point of building this car, is to not only learn, but to take it to competition and get it to stop at a target distance and be competitive with schools from around the country doing similar things. Um, so to win a competition, we need to know exactly how long the car will run for. And based on our stopping mechanism, the car will run for as long as the hydrochloric and magnesium uh, are reacting. So the best way to solve a problem with inconsistencies in how the car is running is to determine a rate law of this reaction. And a rate law is a mathematical equation that will tell you how long a reaction runs for based on how much reactant you put into the reaction chamber. So my research involves a lot of testing um, different concentrations in the reaction chamber, timing how long that reaction happens, and then plotting that curve versus concentration, and then determining a mathematical equation that fits those points. So once we have that mathematical equation, we can save a lot of time, effort, and money in the lab because we can just plug in concentrations and theoretically see how far our car is going to go. Um, if the rate law is good, the car will most likely stop where we think it will. Uh, that's invaluable just because then we don't have to test every single individual concentration of reactants, specifically hydrochloric, uh, that we could potentially use at competition. And that's just not feasible, and it's the way we've been working in the past. So if we have a mathematical equation, as opposed to doing grunt work in the lab like that, just testing every single concentration, the mathematical equation is just much more efficient. So that's the reason I'm doing this research. That's the reason um, that the Chemicar team wants me to do this research, and it's a very helpful thing to do. Rate laws have been researched in depth throughout history, so they've been done on multiple chemical reactions, but not necessarily in a reaction chamber like we have on the car, and not necessarily in the same conditions. So they're always a bit individual. That's why this research needs to be done empirically and not just found online somewhere. Uh, Thank you for listening. Hope that you support this research. Thank you very much.